Hello and welcome to part 2 of the recording for Unit 4, Lesson 8. So far we have proved theorems about isosceles and equilateral triangles, and we have applied properties of isosceles and just started to apply properties of equilateral triangles. So we are going to pick up where we left off. And so here we're given triangle NOP, and this triangle is given 3 congruent angles. And so by one of the theorems we discussed in the last recording, when a triangle has 3 congruent angles, we know that all 3 sides are therefore congruent. So because we are given angle O is congruent to angle N, which is congruent to angle P, that's given, we can then state that all 3 sides are congruent. NO is congruent to NP, which is congruent to OP. And that theorem was the equal angular triangle theorem. And so because of that, we have expressions for NO and OP. So if they are congruent segments, then we know their lengths are equal. So I can say that NO must equal OP by the definition of congruent segments. And now I can substitute in their expressions and solve for y. So 5y minus 6 must equal 4y plus 12. And that is just using substitution. Now solving this equation, I need to get all of the y's together on one side of my equal sign. So to do that, I can just subtract off 4y from each side. You'll see that these y's cancel, leaving me with just 1y minus 6 is equal to 12. So that was just algebra, or more specifically the subtraction property of equality. And now I can get y by itself by just doing the opposite of adding 6 to both sides. So that's, again, more algebra or the addition property of equality. And that gives me that y must equal 18. Alright, so now that we have applied properties of equilateral and equiangular triangles to solve problems, let's do a couple proofs together to finish up today's recording. So here we are given a diagram, and we are given that angle VUX is congruent to angle VUX is congruent to angle WUX. That's given on the diagram. We are also given that this segment here, VW, is perpendicular to XU by that right angle symbol. And our goal is to show that WX is congruent to VX. So let's see how this proof works. I'm going to start statement 1 by stating that segment VW is perpendicular to segment UX. That was given to us. We can see the box in the corner of those segments. The next statement is that angle VUX, that's this one, is congruent to angle WUX, that's this one. Again, given to us in the diagram. Now, looking at these triangles, and looking that I was given a box in the corner of these perpendicular lines, then that means that not only is angle UXW 90 degrees, but so is UXV, because the box implies both are 90 there. So I can say that angle UXV is congruent to angle UXW because all right angles are congruent. Okay, they both equal 90 degrees. From there, you can see that we're showing these two smaller triangles congruent, and then we can then use the theorem we talked about from Monday's class to determine that if once the triangles are congruent, then all remaining pairs of corresponding parts are then going to be congruent. So I see that there is a side shared by both these smaller triangles, and that is side UX. So I can say that UX is congruent to itself using the reflexive property of congruence. So now I've got to look through my proof and see how I just proved those triangles to be congruent. If you look, I've got an angle here, the side in between, or the included side, and another angle of each triangle. So I have angle, side, angle. And so that is one of the 5 ways I can use to prove triangles are congruent. And then once I show my congruent statement, then I can say that the pair of parts that I'm showing to be, that my goal is to show congruent, are congruent, and that follows up the congruent statement just using corresponding parts of congruent triangles are congruent. So remember from Monday's recording, you first have to show the triangles are congruent, then you can use CPCTC to show all remaining pairs of corresponding parts are congruent. Okay, let's try one more together. All right, here we want to complete the proof showing that TV is congruent to UV. So right there, that's what we want to show. That's got to go in our last statement box. So let's walk through what we're given to start with. Statement 1 says angle TSV is congruent to angle USV. Well, TSV, that's this angle here, and that's given to be congruent to this angle. So the reason is given. The second thing we're given is that angle U with 2 arc marks is congruent to angle T with the matching pair of arc marks. So angle U must be congruent to angle T. That's also given. Now remember, it's always easy to look for any common parts shared by triangles. And again, we see that here. So one more pattern that we should get used to seeing, and that is SV is shared by both the top and bottom triangles. So SV must be congruent to itself by the reflexive property of congruence. So now I've shown one angle here is congruent to this angle, another angle over here, and then I've shown the not included side, right? This side right here. So the method we showed triangle STV congruent to SUV was angle, angle, side. And then last of all, TV is congruent to UV. I've already shown the triangles are congruent, so therefore all remaining pairs of corresponding parts are congruent, segment TV and UV, by CPCTC. Alright, so now I think it's time for you guys to practice in IXL on your own to get ready for the test that you'll be taking at the end of the week. That'll be your Unit 4 test. And so here's the IXL that you guys can practice, involving K8 congruency in isosceles and equilateral triangles, and then K9 proofs involving isosceles triangles. So make sure when you are completing your IXL practice that you log in so that it's tracking your progress. Okay, I hope you guys are having a good week. If you have questions, please feel free to email me, as remember I am out all week for testing, but I will be checking my email every day, so I'll be able to get back to you guys if you have any questions. Thank you so much for watching and have a great day.